Welcome, everyone, and thanks for joining today's strategic briefing. So today we're taking a look at something that, well, on the surface, probably sounds like a highly technical, deep-in-the-weeds engineering topic, cabled tray load capacity. But we're going to translate that into what it actually is, an absolutely critical business and risk management issue. You see, when we look at large-scale infrastructure budgets, the structural integrity of these systems isn't just about cables and steel. It is fundamentally about safeguarding your project's long-term commercial value and, frankly, avoiding massive hidden liabilities. Okay, let's dive into this. A catalog load class is not a project rating. Sounds incredibly simple, right? But I've got to tell you, this single misconception is a massive financial trap. Far too often, procurement teams and project managers, they look at a manufacturer's catalog, they see a standard rating, and they falsely assume, great, this guarantees project safety and compliance across our specific site. Well, actually, scratch that, it absolutely does not. And treating it as such, you're literally risking your entire capital investment. So to unpack this today, we're going to walk through a clear risk-to-reward framework. In this explainer, we'll quickly cover hidden procurement risks, the core commercial variables, the exponential threat of span shifts, a four-step decision method, hidden costs, and finally, the Xinma advantage. Starting right off with Section 1, hidden procurement and compliance risks, and why catalog ratings are essentially myths. Listen, we need to completely shatter the myth that a catalog rating is some sort of magic bullet. Because if your organization is currently treating a catalog load rating as a guaranteed rubber-stamped project rating, you're carrying a massive operational liability on your books right now. So what exactly is a catalog load class? It's just a specific, highly controlled test combination of three things: span, load, and deflection. The absolute key takeaway for anyone signing off on procurement contracts is that this is a fluid scenario. Think of it like a seesaw. If you change the span on the actual construction site, the load capacity inherently changes. If the load changes, the deflection changes. Only one of these variables can stay fixed when the others move. It's just an isolated data point, guys, not a static guarantee for your real-world project. Moving on to Section 2, core commercial variables of capacity, or the levers of your budget. Now, what's really interesting about these four structural levers, tray type, rail depth, width, and material, is that to an engineer, sure, these are just standard technical specs, but to a C-suite executive, these are the exact dials your procurement team is turning to balance cost against structural integrity. Opting for a cheaper material or maybe a shallower rail depth might look fantastic on a Q1 spreadsheet, but you have to understand it directly and permanently degrades the system's load capacity. We really need to grasp how these variables interact to truly protect the overall investment. Which brings us to Section 3, the exponential risk of span shifts, also known as the cube of span threat. This is perhaps the most critical risk factor we'll cover today. We really need to look at what happens to your commercial baseline when site conditions inevitably change and the support spacing shifts. There's an undeniable rule of physics you just have to know. Deflection grows with a cube of the span. This isn't just a fun physics fact. It is a severe executive liability warning. Deflection is simply how much the tray bends or sags under weight. And if it sags too much, cables stretch, connections break, and suddenly you're looking at catastrophic network or power failures. Because it grows with the cube of the span, even tiny changes in how far apart those supports are placed create massive, compounding risks for your maintenance budgets down the line. And this brilliantly illustrates exactly what we're talking about. Let's compare a standard 2-meter span against a 3-meter span. Imagine you've got a busy manager on site who casually decides to increase the distance between supports by just 1 meter, just to save on installation time or material costs. It feels like a simple 50% increase in distance, right? No big deal. But because deflection grows with the cube, that simple decision exponentially skyrockets the risk of a structural failure. That single, seemingly minor site decision can literally destroy your commercial viability and safety margins. All right, Section 4, our 4-step procurement decision method, how we actually read these tables for real projects. So what do we do about this? We've got to shift from identifying the problem to actually implementing a solution. And that means a mandatory 4-step workflow, really a structured governance model for your engineering and purchasing teams. Step 1, identify the real project span based on actual unpredictable site conditions, not the ideal ones on paper. Step 2, determine your actual load requirements. Step 3, once you have those realistic numbers, then you check them against the catalog load tables. And finally, Step 4, calculate the deflection for those final real-world conditions. Implementing this specific framework is exactly how you bridge the gap between catalog fantasy and project reality. Section 5. Hidden Costs and Future Project Margin. This is all about protecting the investment. This framework we're talking about, it's all about future-proofing your infrastructure. You have to understand the true total cost of ownership before any procurement deal is finalized. When you're evaluating that final load case, it is never just about the base load of the actual cables. You absolutely must account for covers, accessories, and, crucially, future margin. Here's the bottom line. If your team only calculates for the base load on day one, you are baking in hidden costs immediately. When protective covers are added later or accessories are bolted on, the load spikes heavily. More importantly, if you don't build in a future margin for inevitable expansions or technology upgrades, you're going to be forced into incredibly expensive retrofits. Overlooking these slices of the pie is a direct hazard to your profitability. Finally, Section 6, Building Reliable Foundations with Xinma through Standards-Compliant Execution. Now that we've outlined the financial risks and the methodology you need, we have to talk about execution. To pull this off safely at a high strategic level, you need a reliable partner. And Xinma is an expert manufacturer specializing exactly in this: cable tray systems, busway, seismic bracing, and intelligent cable management solutions. They are actively operating in the highest stakes mission-critical sectors out there: data centers, rail transit, massive industrial plants, and complex commercial buildings. In these rigorous environments, a structural failure isn't just a headache, it equates to millions of dollars in downtime and severe corporate liability. Xinma brings the technical rigor that is absolutely required to execute safely in these exact scenarios. And they back up that execution with extremely rigorous global compliance. Xinma's products map directly against the strictest international benchmarks. We're talking compliance with IEC 61537, NEMA VE1, BSEN 50085, and GB 31251. Now, for an executive, I know this might just look like an alphabet soup of technical codes, but it's not. This is pure, direct risk mitigation. Aligning your procurement with a manufacturer that inherently meets these global benchmarks is an essential strategy if you want to secure the long-term commercial value of your infrastructure. Well, we've covered a lot of crucial ground today, really translating those abstract engineering variables into hard, real-world commercial impacts. So, as we wrap up this explainer, I want to leave you with one final provocative thought. Is your current procurement based on a catalog myth, or is it grounded in project reality? Seriously, it is time to audit your specifications. Go ask the tough questions of your procurement and engineering teams, and ensure your project foundations are built on solid, verifiable ground. Thanks so much for joining me today, and I highly encourage you to take this strategic framework straight into your next board meeting.